Alrighty everybody, welcome back to another Redstone video. I know I haven't been doing too many of these lately, but that's about to change. We're going to start doing some more Redstone videos. So today, we're going to be building a calculator because, you're just sitting around your Minecraft base, you're just thinking to yourself, like, I need a calculator. I need to add some numbers together. So, I've just built the interface right here, so you get the reset button, which resets your input. And then this button will toggle what memory you save the input to, so we can enter in our numbers in binary. So we'll just put in like 1, so that's 3, and then we'll put in 11 right there, and then you would that would input it into whatever memory selected. So this would then write it to the memory. So actually we'll need to make a button over here to write the memory right here. So this button will actually write to the memory, and actually we'll switch these around. So grab that, put that over here. We'll just switch these around so that it makes a little bit more sense. So this doesn't need to be here, and we can build it up again over here. So the way this works back here is you have your buttons which power these alternating repeaters in Redstone Dust. This is so that it has as little delay as possible. And then if you notice where you have the redstone dust is where the repeaters are, so that it tries to make all the timings the same. So like if we hit these two buttons really close, they're pretty close together. They're a little bit off because, we didn't push them at the same time, but you get the idea. So then that activates this piston with an observer, which then will make these pistons spit out their blocks, which is then where we take the output from. Alrighty, so I just finished creating the bus and the memory circuit through over here. So I think it's starting to look pretty awesome. With the input, I did add this line here, which inverts whatever you have here. So everything was off, now it's all on. And if we just kind of push those two, then those two will be on and everything else will be off. So it inverts it, and that's just by extending all of these pistons, which will basically flip the output of whatever these redstone blocks are. So it's pretty simple. Don't know exactly why you would need it, but I figured I would add it just because. And then, of course, we can reset our input, and this also is going to reset all of the memory modules, which we only have 2 for now, but we could add more if we wanted to. So the red circuitry is the reset circuitry, so all of that is for resetting the memory modules as well as the input, and then the gray lines here are is memory control, and then this other gray is your memory output, and then of course the green down here is the bus. And so the way this works is when you input actually we'll just invert it so all of them are on, is all of these lines turn on, so we split it so that each one can have its own kind of road without interfering with each other, and then they kind of go over this hump and continue on through. And so the way it works is when we activate the memory modules, these pistons get raised so that this redstone dust will reconnect here, activating the memory circuit, which will then store our data and then be outputted on this line here and this line here. So if we just go back to our first memory module, you'll see some stuff changes. That's activating this. So this redstone torch is off, which means that when the memory is written to, this line will activate, turning off the redstone torch, allowing all these pistons to raise so the data can go through. And then to avoid issues, we also have it on a delay, so it also will activate the reset for the memory, so that the memory gets reset before writing the data. So if we write the data, we can see, oh, we missed it. Wrong button. Reselect that. If we write to the memory, we can hear everything start activating, and you can see all of these are now on. So now we can toggle our memory. So we switch to the other set of memory, and we'll just write something else in there. We'll just alternate them like so. And now you can see that our memory is, okay, we goofed. Alright, so it activated the reset for both memory modules. So the next thing we gotta do is make sure that it does not reset our memory if it's not the one being used. Alrighty, so I fixed the issue with the memory circuit here. I tried to piggyback and cheat and use this signal line for the reset to do the memory logic for me, but that ended up failing, so I just added this extra little circuit here. So basically, when you hit the memory right button, the signal will travel down through here and try to reset the circuit so that the memory can be written. But if that memory circuit is not selected, so if we unselect that memory circuit here, it will extend this piston, cutting off the signal so that this memory circuit will not be reset, and it does the same thing for this side as well, making sure that it can't be reset if it's not selected. That way we can keep our data in there while writing to the next set of memory. So then what I did is, for the memory circuit, I am using cyan, terracotta, and concrete. So for our first bit, I'm using, actually, we should probably switch that around we need to switch that around because this is 0. So all we got to do to switch which bit is which is just to come up here and invert the signal. There we go. So that way this one is 0 and this one is 1. So that way when we put it into the adder, it's in the correct thing. So basically what I did is I have our memory circuit 0 and 1 be two different colors of cyan terracotta and cyan concrete, so that we can distinguish which is which, because else building up this circuitry is a mess. It already still looks kind of like a mess, but basically we're taking the output from each memory module and we're kind of passing it around, and so the ones place of our first memory circuit is right next to the ones place of our second memory circuit, and so on and so forth. And so that way, from this point here, we can actually start building the binary adder so that we can actually add our numbers together and then take our output and display it. So so basically this is a micro version of the binary adder that I'm going to use. I've used this in other computer projects that I've done. Unfortunately, I can't show you any of them because the world that had all of them in there got corrupted a while back ago, and then it got lost, and so it's no more, unfortunately. But basically, if we grab a lever, these are going to be your inputs and outputs for the binary circuit. So we got our two ones. So if we have 1, 1, our output is 1. If we put on 2 1s, 1 plus 1 is 2, so it puts it into the 2's place of binary. Then if we put a 2 in there, it continues to carry over, and now we have our 4's place. Because 1 plus 1 is 2, plus 2 is 4. Then if we put another one on, we will have the 4's place, or the 2's place on here. So now we have 6, and we can continue adding, and we do this, and now we have our carryout signal, which is going to be our next bit of operations, and then we can plug another one, and all of them are on except for 1. And so basically, we're going to build this, only we're going to extend it, so instead of having 3 bits, it'll have 8 bits, and then we will take the output from that, and then we will loop it over and hopefully be able to fit the display in here so that it kind of creates this nice little addition machine, just kind of all neatly packed into a little area. Okay, it's kind of a big area, but you get the idea. Alrighty, so I finished building the adder circuit here and getting it all wired up with the orange wires, and it's actually looking pretty sweet. I tried to make it as compact as possible. Obviously, there is a little bit of space in between here and in between here a little bit, but that's about as compact as I can make it right now, although I'm sure that if I really wanted to, I could make it a whole ton more compact. But besides that, it's all done. Let's pop back into creative mode here, and let's see what this thing can do. So if we select 1 for bit 1 and hit that, all the lights light up, which is kind of cool, but it's just a side effect of everything propagating through. We get 1. If we switch to our second byte of memory, and we also put in 1, then this will do its funky stuff, but land on 2. So for all of you who may not understand binary fully, binary is base 2, so each state has 2 states. So the first section is going to be 1, then 2s, 4s, 8s, 16s, 32s, 64s, 128s, 256. And obviously this is 9 because our carryout bit will come in here. For example, if we just reset everything, which looks really kind of cool as everything is lighting up and doing its thing, and we put in 256, or no, that would be 128, write it to there, wait for it to do that before switching, and then we change our output and we add it again. Now we're going to have 256, so it will light up the last lamp. And so that's why it's there, because if we add too much together, it will overflow. Alrighty, so I just put up some signs here so that we can tell a little bit more easily. We can do a couple more examples. So we can go ahead and put like 3 into register 0 and switch it to register 1. And we can go ahead, let's go ahead, put 3 plus like 17. So 17 is going to be 16 plus 1. Write that and wait for it to compute. And so, as you can see, our output is 20, because 17 plus 3, 17 plus 3 is 20. So, another cool thing that's kind of cool to see if it will do it correctly is we'll put in all of these, like so. Oop, I double clicked. Write that. And they'll show up. Then we can do like that. Alright, and then we can just invert the output and click 1. And does this do? Oh, no, that didn't really do what I thought it was. Oh, yep, here it goes. It's like boop, boop. It's kind of cool. So there you have it, everyone. We got a simple little 8-bit binary calculator right here in our very own Minecraft in 1.15.2. And so we got our memory, we got our buses, so we can store our memory, we can select our memory using the gray circuits right here. Then we add our binary using this blue circuit here, taking each numbers in with the 2 colors of cyan into the sides, and then our output is flowing over the orange and going into the top over here. So overall, I think this is a pretty cool circuit. If you guys enjoyed, please leave a like on the video and feel free to subscribe as well.